Okay. Do you have permission to share? Yeah, I'll share.
Yeah. Should be all good. Is it good? You see it?
Yes. Looks good. Yeah, so I'm putting it's on a live stream, so there might be questions in a YouTube chat.
There, I think, or there's somebody outside.
It could be outside people too. Yeah, but they're not like live in terms of on a call. They're just watching through YouTube.
Okay. We get started or wait a bit more, or
Yeah, people will roll into the next segment or two, and then maybe get started.
okay, then let's get started. Hello, everyone. Nice to see you here. So this workshop is going to be quite technical, diving right away. So I'm not going to talk about sort of vision and that sort of stuff. I will just go straight to code to be, get you started how to use our agent tag, how to build on Fetch. So to get started, you might know Fetch is all about agents. Agents are able to communicate with each other, and they take care of the networking details of how to sort that out for you, how to easily be able to create Python programs which can easily communicate with each other. And we also do a lot of services around agents. For example, on AgentVerse, we have hosting, which takes care of how to run, how to deploy your agent. And then mailbox service, which you can use in order to connect to other agents. For example, let's say that you're in a team, every member of your team is working on an agent. And the question is now, you want to test out your solution, and then your agent needs to connect to the other person agent, which is running on another computer. So usually you have the issues with Wi-Fi being behind some sort of node on the router, and you're not able to directly call or communicate easily. So what you can do, you can use the mailbox service from AgentVerse, which takes care of this problem for you, and then you can easily communicate. And I will go through some code and show how to do this and how to get started. Just before going to code too much, so whenever you want to look up something, the main page you should go is Fetch.AI/docs. And then here we have some guides. This is all the code, all the examples and workflows, how to do stuff. By the way, anytime during my workshop or when I'm showing some code, you have any question, you have any confusion, just don't hesitate and ask, and then we can stop and discuss your questions. Okay, and let's go to AgentVerse and let's build our very first agent here. So this is AgentVerse. You can sign in, you can sign up to the website, and then you are getting some compute credits, meaning you can run agents, the agent can live there, and then you're getting all of this for free after you sign up. And on AgentVerse, if you go to My Agent, here you see this new agent button. If you click here, then this pop-up will come up where you can see there are some use cases already here, some pre-made agents for you, which can get you started. So let's go and click on our first agent, and let's go through the code and what you see here. Okay, so this opened up our editor, and then here you see the code of this simple agent. So the first thing you do, from this UAgents Python package, you have to import these different agent and context objects. And afterwards, you are creating this agent object. And the way developing agents with Fetch.AI works is that what you do is you implement specific logics, your stuff effectively as async functions in Python, and then you are going to decorate with agent, for example, on interval. And there are a few decorators we provide via this agent object, and then these are providing some specific functionalities for you. Here, this is the first decorator you encounter, which is this on interval, means that this is sort of this function will be executed every 3 seconds. So this is sort of an easy way of setting up a periodic task. And then this, a common pattern here is that all of these functions which you are decorating with these agent methods, they are getting this context object which gives you access, for example, for logger and other functions you can use. And now if you go and run this simple function, then you will see that this periodic task is executing, and then it's printing out these log messages for you. This is a fairly simple agent. It's not doing anything exciting, but sort of the key takeaway from here is that you create an agent object, a simple agent object, and then you are using this agent object to decorate some Python methods, which will be your logic or whatever functionality you envision to have. So let's go and add a bit more complication, because this is not doing any communication or any fancy stuff like that. So let me go here and quickly delete this agent. And then let's repeat the process and let's create the second agent, the second case. This is the example of communication, and this will actually, when you click this one, it will create 2 agents for you. Okay. Can I zoom in? It's
on the code, maybe zoom in.
Okay. So this use case creates us 2 agents, Alice and Bob. And let's go and check what's going on inside Alice. Let me try to zoom in. Oh, that's not it. Is it better now? Okay. Let me add a bit more. Oh, that's too much. That's way too much. That means actually, okay. Okay, so first line, exactly the same. You create an agent object. And then, as I said, we are repeating the same pattern. We are using from this object different decorators. And in order to do the communication, as you see, it's actually not much more code than compared to that simple on interval. What we are now doing, instead of on interval, we are using this on message. What does this mean? That effectively, when this agent is getting a message of the specified type, which we pass in here, which is defined here, I will talk about it in a moment, then this code logic is going to be executed. So anytime somebody sends, another agent sends a message to your agent, then this function, this Python function will be executed for you. And now you see there are some extra pieces of arguments in that function. Again, we have a context, now we have a sender, and we have a message, which was the actual message sent to the agent. What is the message? The message is annotated with this request type, so effectively you can create any Python class, as long as it's inherited from this model class, which is again imported from our microagents library. And then you define all the fields you need, or all the data your agent can speak. Effectively, this is, you can imagine you're defining what is sort of the protocol, what is the detail, what is the data block that agent can handle. And then when somebody sends your agent that agent address a message which fulfills this model, then in that case, this method is executed. And then you're also getting who is the sender. So in our tech, one fundamental part is that when you are getting a message here from somebody, then the system verifies you that it's actually who the sender is, that's actually that person. So the way it works, an agent has an agent address, which is effectively a public key belonging to a private key. And then each message you are sending or sending to agents, effectively all of those messages are signed with the private key. And then the system, the UAgent framework, is going to verify for you that is the sender actually who he claims to be. And again, here in Alice, we have the same interval handler, which is going to execute in every 3 seconds. But now we are doing something else here as well. So previously we just only had that part. So we had a non-interval, which is logging out some message. Now we added some bit of complication, a few lines of extra code to enable communication. And now the question is, how can we send a message? So for example, here, inside this handler, if you use this context object, you can use this send message. And then you specify what is the agent address. And then we choose what is the message. And then we send this request message equals hello there, Bob. So what this means that, sorry, it's really weird if I'm looking here and I'm trying to scroll on my computer. So what we have here, so every 3 seconds, what's going to happen, this agent is going to send a message to this address, and it's going to send a message, hello there, Bob. And that's it, every 3 seconds. And let's go and have a look on the other agent of this example. So here is Alice. Again, similar pattern. We create an agent object, and then we use the decorator. And sorry, we have to check both. I was actually checking Alice. So what is Bob doing? So again, it creates the agent, and then now it is using only this decorator on message. What is it doing? When it gets this message, then it's going to print out what is the message, and then it checks if the sender address is that one. This is, by the way, the agent address of Alice. Believe me, so the example is set up in a way that when the agent address is indicated, we are pasting it in the code, so it must be right. And it checks if the message is coming from Alice, and then if it's coming from Alice, then it sends back a message, hello there, Alice. If it's coming from somebody else, it's going to send a different message. So now if I start running this agent by clicking here, then we will see actually nothing much happens. This doesn't have an on interval, so there is no setup task which is running. It's just sitting there and waiting. But now if I go to Alice, and I start Alice as well, then now we should start some stuff going on. So just about to send a message to Bob, we sent a message to Bob, and then we see that we are getting a message from the other agent. So this is really it. So this is how easy it is to set up communication between two agents. You don't have to care about what are the networking implications. You don't have to start a web server. You don't have to set up all of those pieces manually. Simple function, implement that handler. This is the message you are handling, and then send the message to an agent address. So this is how easy it is to get started with agents communicating with each other. So as a next piece, what I want to talk about is, for this hackathon, we put together a few agents which you can utilize. And effectively, the way it works, you just go and send a message to this agent, and then it fulfills its service. So I compiled this document, and I also put a QR code and a tiny URL to to that document. If I move this a bit out, please do take out your phone and make a picture. And I am going to work through these agents on the super high level to get started using these. If everybody is good, not the slides, only the document I'm going to talk about. So this QR code and this tiny URL code here you see that's pointing to that Google Docs, where I just collected you these few agents for you. Okay, let's go to the document now. So in this document, effectively, we have some name for the agent, some high-level description. So the first agent we have here is a simple OpenAI wrapper, which wraps GPT-4o mini. So here we have some links. And if we go and click on this link, then this opens up this explore page of that agent. So you see that this agent is running on Agentverse, and here we have a nice readme about the agent. So this readme contains effectively all the code for an example code you can use in order to communicate with this agent. So what do you need to send a message to this agent? This agent is expecting this type of message. So this prompt class, when you have a context, which is a string, and a text, which is a string, and it's going to respond back to you with some string. And then we have the agent address. So this is the address you have to send a message to. Effectively, you copy out this code, and then you can customize this code from the README. And then when you send this message, you don't have to set up any OpenAI account or anything. You don't need a key, so you can just use GPT-4o mini LLM while communicating with this agent without setting up any credentials, really. So this is one of the examples. And similarly, we have Gemini for code generation here. Again, if you go and open the link, then we have in the README the example of how to use this agent, which you can just simply go and copy out quickly and get started. Again, we have an agent created for this hackathon, which is Claude AI. Again, similar structure from the README, you can copy out the code and then easily use that other LLM. So really nice thing, you don't have to set up all the different packages, all the different accounts and access key. You just can switch the agent address and then use the other LLM. And then you will see in the documents there are a few other agents. For example, there is this nearby agent which can provide you search, effectively find places near your query. And there are some, if you are interested about real-time flight information for your use case, there's an agent for that as well. Of course, there are many more on Agentverse, so go and explore. I just highlighted and copied out a few interesting ones which you might find useful for this hackathon. Yeah.
So you said like we don't need to have the OpenAI's API key, right?
Yeah.
We can just directly.
Yeah.
How many requests can we send like once? Is it like we can do unlimited requests?
So parallelly, you can send as many requests as you want. However, in order to avoid abuse, there is a tracking inside the agent implemented to how much token you are using. And then after a high amount of token usage, is going to start denying or slowing you down a bit.
Yeah.
So you are just not able to exploit that agent and OpenAI in this way.
Yep. No, I was just curious. Yeah.
Okay. Any other questions at this point? Okay.
How many times, like, if I use credits, for example, how much do you charge? Like, do you charge like twice the amount of credit spend, or like is there a ratio?
No, so these agents are not charging anything, so they are free of charge. At the moment, this is specifically for the hackathon.
Yeah, but like,
on sort of on the product side, okay, if you are going in that direction, effectively what we are offering on Agentverse is the hosting service. So we are offering you compute. So if you have agents which require heavier compute, they need some really heavy compute in order to do something for you, and you want to host that on Agentverse, then you will need some more compute minutes, and then effectively you will have subscriptions for these sort of bits. And that's where sort of monetization is coming in as we envision.
What happens when we like run out of one of the my stats options? like storing size or process messages or something.
On agent first, you mean?
Yeah, all this.
Okay, so in that case, you can just during the hackathon, you can just reach out, come find us in the booth, and then we can give you more. But those are fairly high limits, effectively. So an interesting thing about agent-first hosting is that you see there are minutes, compute minutes, but that doesn't mean that when you start the agent, that's sort of ticking. Effectively, when we are charging or when we are subtracting compute minutes is when your agent is actually handling a message. So if your agent is just sitting there doing nothing, then you are effectively not using any compute. Compared to the sort of the classical way of going to a cloud provider and putting up that agent or that code on that VM effectively, and you are going to be charged effectively for the whole time, even if it's not doing anything. On agent-first hosting, we take, we're utilizing this asynchronous nature of agent communication, and only you're being sort of using compute credits when the agent is actually doing some compute. So that's why those limits are quite hard to reach. But if you manage to, just come and find us. Any other questions? Okay, we got a few more minutes. So in that few minutes, I'm going to go and show some more code to you. So another common pattern you might have is that you're building some sort of application where you have a backend, and then backend now wants to talk to an agent. And as you saw, agent-agent communication is fairly easy, but when you want to extend and you want to integrate into REST API, then that's actually not hard either. So in order to get started with that, if you go to the microagents GitHub repo inside the Python, and let's just go through quickly. So you go Python, examples, and then we have this last example as the REST API. So what you can do in order to connect up your agent to with a REST API, effectively, you can use these other decorators. So for example, let me zoom in. Is it visible in the back? Good, okay. So if you want your agent to be able to process a message from a simple GET request without all the signatures and agent-to-agent communication protocol being sort of a complication, what you can do, you can use this on-REST GET decorator. You specify what is the endpoint, and then you simply here, you can handle GET requests. And then similarly, you can do post as well. So all the complication is removed is sort of this agent communication protocol. So your agent, in order to do the communication, actually in the background is already running a web server. So when you start your agent locally, for example, you will see that it's going to start up a web server on port 8000. So the agent communication actually is built on top of HTTP. So agents are running web servers and they are sending HTTP requests to each other. On top of that, we have the agent protocol, which is doing all the sort of more specific agenty pieces of the communication. But these pieces, these decorators, effectively, you can use in order to much more simply connect to your agent. So this can be the entry point. You can imagine if you have a backend connecting to your application, then you can use these endpoints in one of your agents to connect directly from your chunk, fast API, or any sort of backend server to your agent. And then afterwards, you are inside this sort of agent realm. You can utilize agent communication. So one last thing I want to show in the last 1 minute we have here is that how to get started if you want to do if you want to run local agents and you want to make them be able to talk to each other. If all of your agents is running on the same machine, then you don't have a problem because locally you can access localhost and send messages between them. But in cases when one agent is on your machine and another is on your friend machine, that's where things get a bit tricky. So here I have a quick code snippet to show you. So effectively, again, you create the agent locally. One important piece which is now showing up, which wasn't showing up on agent first, is this seed phrase here. So whenever you're creating the agent locally, you will need to provide this seed parameter. This is a really important piece. Effectively, try to come up with something unique for that specific agent. This seed phrase is effectively used to generate a private key. So if anybody knows your seed phrase, they can generate the same private key. They effectively own the same agent address, which can create some issues. So come up with something unique for this. And after you run this code, what happens here is that we are printing out the agent address. Actually, it's a bit up here. So in order to address, we can create an agent, as you see here, with the same seed phrase, and then we can print out the address. So I already did that. I copied out this agent address, and now let's go to this local agents on agent first, and then we can register that agent simply by pasting in the agent address, and then give it some name. And then afterwards, this local agent piece is going to give you a key. Using this key, you copy it out, and then you save it in your code. This is effectively, just imagine, as an authentication key for your mailbox. So mailbox is a service on agent first. Effectively, you can envision that you are running your agent on your machine, and you connect that agent to the mailbox. And what happens in this communication is that when another agent wants to send a message to your agent, what they actually do, they send the message to the mailbox. The mailbox is going to store the message for you until your agent goes and queries from the mailbox. So this is effectively a pull mechanism we have here, which means that you don't have all the issues with the routers and the local network setup. So after you paste in this mailbox key, what you need to provide when you're creating the agent, this mailbox parameter, and then just simply provide this mailbox ID here. In the docs, we have some more examples about it, but effectively, after you create the agent object like this and you're running locally, now anybody can connect to that agent wherever they are. So that's about it. And I think we just overrun by 3 minutes.
Thank you.
Any questions before we go? No.
We'll make sure to make